look at a concept called function notation with you. We've talked a little bit about functions already, and a function is just for every input there's exactly one output. It's a relation. And function notation is when you're using equations to represent functions. And let's take a look at this first equation here. Let's say that you had $20 to spend, and you spend $4 each day. So $20 to spend, you spend $4 each day. That's kind of an important function. If you put in a number for x, the number of days, you're going to get out a number for y, how much money you have left. Now, we're going to change one thing about this function. Instead of writing y, we're going to write f of x. And you might wonder, well, why do we have to change it to f of x? It's just a convention or a nice way of keeping track of our inputs and outputs. So if you write f of x equals negative 4x plus 20, then right below that function you could say, when my input is 2, so put 2 in for x right here. Negative 4 times 2, that's negative 8, plus 20, that's going to be 12. So that's telling me f at 2 equals 12. Input 2, output 12 for this particular function. And then we could do f at 3. 4 times 3 is negative 12, plus 20 would be 8. And you could kind of go in reverse here. You could say, okay, when is my output going to be 0? Well, we know negative 4 times 5 is negative 20, and add 20 to that, you get 0. So it's after 5 days, you'll be at $0. So that's one reason why we use function notation. It helps us kind of match inputs to outputs. There's another reason we use function notation. Let's go ahead and graph this first of all. Let me take a second and graph this. And it looks something like this. We've got maybe days here and money left here. And so we're at 2 days, we've got $12. Let's go 4, 8, 12, 16, 20, 24, 28, maybe 32. So at 2 days, we're at $12. Here's 2 days. At 3 days, we're at $8. There's 3. And at 4 or 5 days, we're at $0 there. Okay, so something like that, and we could probably fill in some blanks here because we know it's a linear function. And it looks something like that. And I'm just going to call this function, I'm going to label this f of x. So this is f of x. Now let's say that this is you and you wanted to kind of compare yourself to your friend, and this was your friend here, but your friend's g of x equals, let's go negative 5x plus 30. Negative 5x plus 30. So let's plug in some points. So let's go g at maybe 0 days. G at 0 days is going to be, what's 5 times 0 right there? 0 plus 30 is 30. So 0, 30. And then let's do, so it's 30. And g at 1 day is going to be, well, 25. So 1, you're at 25 here. And at 2 days, you can probably figure this out. You're going down by 5, so you're at 20. 2 days, you're at 20 there. And at 3 days, we'd be at 15 right there. And at 4 days, we'd be at 10. Let's see, 10 right there. And at 5 days, we'd be at 5. And then 6 days, we'd be at 0, something like that. So if you have two functions that you're looking at on the same graph, it's nice to be able to identify one function as g of x, your friend's amount of money after so many days, and the other function as f of x, your amount of money after so many days. And if we used y for both of them, it would be hard to know the difference between them. So two reasons we use function notation. First of all, to keep track of the inputs and outputs, and second of all, we're going to start looking at more than one function on the graph at a time, and so we want to keep track of which function belongs to which. I hope this was a little bit helpful for you. I'm going to sign off here, and thank you very much. This was a tutorial on function notation.